Synthetic division provides us with a shortcut to polynomial long division. However, it can only be used if the divisor is linear. Let's recall that this polynomial is the dividend and this is the divisor. Our dividend is degree 6, but the divisor is degree 1, which means that the divisor is linear and we're allowed to use synthetic division. In synthetic division, we start with a division box that is a backwards L, and what we're going to put in here is the 0 of the divisor. As a reminder, a 0 is an x value that causes some quantity to be 0. So the 0 of the divisor would be the x value that causes the divisor to be 0, and in this case that would be 2. So the 0 of the divisor goes in this box. Now in synthetic division, we focus our attention on the coefficients of each of the terms. We're going to drop the x values while we divide. So the position of each of those elements is extremely important. If we're missing terms, like we're missing the x to the 5th power term and the x cubed term and the x term, we must hold space for those terms with zeros. So our dividend needs to be written in descending order, meaning that the highest power goes first, and the rest of the terms cascade down from there. And we also must use zeros for any missing terms. And so let's begin. To the right of this box, we are going to write the coefficients of the dividend, and we'll use zeros for any missing terms. So the first coefficient is 7. We're missing the x to the 5th term, so we hold that spot with a 0. The x to the 4th coefficient is negative 5. We're missing x cubed, so we hold that spot with a 0. The x squared coefficient is 3. We're missing x to the 1st, so we hold that spot with a 0. And the constant is also considered to be a coefficient, so we write that value down here at the end. Once we've written down all our coefficients, we're going to draw a horizontal line here, and we're going to leave a lane of space under our coefficients for some work. And now we're going to begin the division process. We start by bringing this first coefficient down. So 7 comes down. Then we're going to take the 2 and multiply it by the 7. So we're going to be multiplying on the diagonals. And that product is going to come up and under the next coefficient. 2 times 7 is 14, so that comes up under the next coefficient. Then we're going to combine down. 0 combined with 14 is 14. And we repeat this pattern, multiplying 2 now by the 14. That product comes up under the next coefficient. 2 times 14 is 28, and 28 is written under the 5. Again, we're going to combine down. Negative 5 combined with 28 is positive 23. We multiply on the diagonal. 2 times 23 is 46. And we combine down. 0 combined with 46 is 46. And again, we multiply on this diagonal. 2 times 46 is 92, and that product is written underneath the next coefficient. We combine down to get 95, and then multiply on the diagonal. 2 times 95 is 190, which is written under the next coefficient. We combine down to get 0 plus 190 is 190. And then finally, we multiply on the diagonal again. 2 times 190 is 380, which is written under the last coefficient. We combine down again to get 389. This last number gets chopped off and is actually the remainder from the division. And these values here are the coefficients of the quotient. So back up here at the beginning, we have a 6-degree dividend, and we're dividing by a linear expression, which has degree 1. If we take a 6-degree polynomial and we divide out a degree 1 polynomial, the quotient will be degree 5. So this leading coefficient is going to be on a degree 5 term. So let's talk about what the dividend, the divisor, the quotient, and the remainder are. Again, the dividend was the original quantity, and the divisor was the linear expression x minus 2. The coefficients of the quotient are right here, and the quotient has a 5th degree. So the quotient will be 7 as the leading coefficient on an x to the 5th power term, plus 14 is going to be the next coefficient on the x to the 4th power term, plus 23 is the coefficient on the x cubed term, plus 46 is going to be the next coefficient on the x squared term, plus 95 is the coefficient on x to the first power term, and 190 is the constant term. And as we mentioned before, 389 is the remainder. When we have the division of two polynomials, a common way of expressing the answer is to write it in the form of quotient plus remainder over divisor. That enables us to take an improper rational expression, and this rational expression would be improper because the degree of the top is greater than the degree of the bottom, and write it in that mixed number form. So the quotient was 7x to the fifth plus 14x to the fourth plus 23x cubed plus 46x squared plus 95 plus 190 plus the remainder of 389 divided by the divisor x minus 2. And when we write our answer following the pattern of this mixed number, the expression on the right is algebraically equivalent to the division problem that we started with.